We're going to be demonstrating Newton's third law of motion today with my demonstrators. Let's do it.
Most people have played tug-of-war at some point in their life. A person or a group of people grab the ends of a rope and try to pull the person or group at the other end, usually past some marker, thus proving that one of the groups is stronger. All three of Newton's laws can be seen very obviously in tug-of-war.
Good evening, I'm Zachary Sankar of Miss Denny's Period 3 Physics class. I will be demonstrating Newton's third law of motion by way of tug-of-war today. This is me in the white jacket, and here are my two demonstrators plus one more. Once again, I will be demonstrating Newton's third law of motion, and later I will explain to you why this relates to Newton's third law of motion. Thank you.
I will begin by showing you two separate demonstrations of tug-of-war and then explaining Newton's laws of motion within those demonstrations.
Those two demonstrators will be on that side. We will be on this side. The black glove, once it passes one of the blocks, then that team wins. Take your position. Come on. All right, ready? Pull. This will be demonstration number 2. On 3. 1, 2, 3. Come on, dude. This is us. This is us. Pull! 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 So, this will be our final demonstration of Newton's third law of motion by way of tug-of-war. We thank you all for viewing. 1, 2, 3. Pull! 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 Pull!
There frequently comes a point in tug-of-war, sometimes right at the beginning, but sometimes later, where neither side is moving. Both sides are pulling with the same force, and therefore the rope does not accelerate in either direction. This is a classic example of Newton's first law. Once a net force is applied, such as when one group begins pulling a bit harder than the other, an acceleration begins, and this follows Newton's second law of motion. The group losing ground must then try to exert more force. When the net force begins going in their direction, the acceleration is in their direction. The movement of the rope slows down until it stops, and if they maintain a higher net force, it begins moving back in their direction. The third law is a lot less visible, but it's still there. When you pull on that rope, you can feel that the rope is also pulling on you, trying to move you toward the other end. You plant your feet firmly in the ground, and the ground actually pushes back on you, helping you to resist the pull of the rope.